We'll start with pyrolysis, just because that's kind of the first step. Gasification is just pyrolysis plus a little bit of oxygen to deal with our pyrolysis products. But our pyrolysis in general is a thermochemical decomposition of the organics. It's not an oxidation reaction like gasification, which is a partial oxidation, and incineration, which is complete oxidation, ideally. And that is why it's an endothermic process. We have to heat it up, just like putting a cake in the oven. A pyrolysis reactor, we pack our waste into something and then we add the heat, which changes the form of it. And then if we do something with that, we might be able to get the energy back, but we don't necessarily have to do that. And then our products from our pyrolysis reaction are our solid, which is char, which is basically pure carbon, pyrolysis oil, which is our liquid fraction, and then pyrolysis gas. It's typically done in an oxygen-free atmosphere. Things like traditional charcoal making and things like that, there is a little bit of oxygen involved, so it's not like a strict pyrolysis, but there's kind of not a pure pyrolysis or a pure gasification in the world. There's kind of buckets that we try and place technologies into. So oxygen-free is kind of the ideal for pyrolysis. It's typically a lower temperature, kind of a low and slow cooking of the waste rather than a burning of it. And the temperature and the heating rate can be modulated to control what products you get. So if you have low temperatures, like the really low and slow, you'll tend to form a lot of charcoal, and that's exactly how charcoal is made. You'll basically set some wood on fire and put it underground and leave it for a while. If you do a higher temperature, you're going to move towards gases. And if you do a medium temperature, you're going to move towards producing oils. So depending on what you want to get, you can play with both the temperatures and then the rates that temperatures are changed in order to target different compounds. And there's all kinds of reactors used for pyrolysis. Here's a visual summary of what's going on in our reactor. So we've got all our waste coming in the front door. This is a little batch reactor shown here, and then there's pictures of all the products, our char, oil, and water, and then the gas you can't see, but it's there. And pyrolysis gas is a mixture of different things. So we'll get some carbon monoxide, which is flammable, carbon dioxide, which we haven't added oxygen, but there's oxygen in the waste itself. So it's able to form some carbon dioxide. We'll get some hydrogen, which is also flammable, and we'll get a bit of methane as well, which is flammable. So we have a mix of a few things in there. Our oil is going to be all things that are higher molecular weights than the things in our gas. And then our char is basically a matrix of carbon. And there's going to be some inorganic stuff embedded in there as well. So when you actually burn the char, then you'll actually see some of the ash that's left over. The water comes from moisture that's in the waste, as well as water can form through the reaction as well. And as you can see in the picture, it tends to leach out some of these other compounds, and it looks pretty black and yucky. I've also added a screen grab up here from Colin Furz's video, where you can see some of these oil and water components in some of his equipment that's on his machine. So when you start trying to pyrolyze something, you'll end up with all this sticky stuff that you'll have to deal with. So in a gasification reactor, you really want to shift that all into gas so you don't have this situation. But like I said, you can really tune your pyrolysis reactor to get this sticky, oily, tarry stuff if you want it. An interesting case study for a pyrolysis reactor is the Rialto bioenergy facility. This is being built in California right now, and it's interesting because it uses a few different waste technologies all smashed together, and they're all for different reasons. So at the front end, we have an anaerobic digester, which we've seen before. So we've got organic waste coming in. It's producing biogas, which they're sending to combined heat and power application. And then we're also producing this digestate. So they're calling that cake here. So that's just dewatered digestate is called cake. So we've got all this dewatered digestate. We talked about in our organic waste unit, you might compost that or permit it to apply directly to land. In this case, they want to squeeze a little bit more value out of it. So they're drying it, and partially that's using the heat from their biogas to do so. partly it's using some gas from pyrolysis process later down. So I don't want to get too ahead of myself. But we dry our cake off so that we're raising its lower heating value basically. And then that dry cake is going to go into pyrolysis reaction. And again, pyrolysis gives us a solid product, a liquid product, and a gas product. So our pyrolysis gas, they're using in their dryer to help sustain that reaction of feeding the anaerobic digestate cake into the pyrolysis. So we're using our gas for drying. We're using our oil, we're actually sending it back into the digester. So the first pass through, it wasn't able to digest these things and it came out in the cake. Now we've treated it, we've made the molecules a little bit smaller and more edible for our bugs, and we're sending it back into the digester, and that's going to bump up our gas production. And then our solid product here, our biochar, is coming up and it's being sold at the end. So we've been able to use all three of these products and integrate them into a system to really maximize the value that's being drawn from this organic waste that's initially being digested. So this is a pretty unique product, kind of smashing all these things together. But it's, we might see more projects following this example in the future, who knows?